Yeah, today we'll talk about peer-to-peer network-based attacks. Actually, from last week, I was thinking about nodes, how to find attacks in nodes, because previous I was researching and writing paper in software-defined network and blockchain together, how we combine these two technology together. So from that research, I came to so many questions to my mind, and the important thing in software-defined network is control, which control the nodes inside in system. So I was I thought maybe I need to again study the nodes from the beginning and see what kind of attacks happen in peer-to-peer network before blockchain. So today I will show you here this screenshot. I took it last, I think, yeah, 2 days ago. Yeah, it show you here the nodes working in the Bitcoin. It's more than 9,000 something nodes. So as you can see here, this is live map for Bitcoin nodes. And this is only in Bitcoin. There are other nodes, of course, in other cryptocurrencies. So just keep this picture in your mind, and we'll come to it in the next slides. So the next question come to my mind when it comes to blockchain, which is what kind of nodes we have in blockchain and what types. So of course, some of you will know that we have full nodes and light node or CBV node, it's a simplified payment verification nodes. But maybe some of you heard or not, what is burning node, what is archive node, and of course, obviously mining node, all we know that. So I did some digging inside to this nodes, and I find that it's sort of full node and not full node at the same time. So you can see in this circle here, you see the archive nodes and mining nodes and full node, they combine together with the burning node. So I try to summarize and see the difference between all of these nodes. So I came to this table. So as you can see here, full node can propose a new block, no, as we know. Send new transaction, yes. Hold wallet balance information, yes. Hold complete history, yes. Hold some data history of balance sheet, no. So these two type of node, burning nodes and archive nodes, it's, as you can see, it's almost same with full nodes, except the holding of a complete history of a blockchain. And we came to the mining node, we say can propose new block, yes. And this is the only thing can mine block node, which is whenever start a new block, they can start from the mining node. And then light clients, which light nodes also, they call it. And finally, the simplified payment verification node, which is similar to light client or light nodes with, yeah, almost everything. So in today's presentation, let's think of it like we have 4 types of nodes. Number 1, healthy nodes, and number 2, malicious, and client, which is light nodes, or and yeah, Eclipse node, which is a kind of attack happened sometimes in peer-to-peer network, and also in blockchain, especially in private blockchain.
I don't get it. What eclipse the node means? As you know, the malicious node is obvious.
Yeah. Eclipse will come in this next slide. Eclipse attack, which is kind of nodes come between the victim node and blockchain network. So it's isolate the victim node from getting information from the blockchain network. So there is no transaction come, there is no any information. Like if he send one transaction, the transaction will not go. The attacker node will say there is no balance, for example. So this is one type of Eclipse attack. Also here, how can the victim node or the attacker node like isolate the attacker, the victim node? It's by the mining power. So in this example, we don't need to like take 51% mining power. All we need is just 30%, and some kind of times we need just 20% or 10% of mining power to isolate the victim node from the mining from the network in total. So this is the one.
You mean the attacker node isolate the victim node and then
Yeah.
give a wrong information?
Yeah. So the information will come through the attacker node. So the fund will come here, and the attacker will say there is no balance. For example, they will say the refuse fund will take it from inside the victim node. So everything will be controlled from here. As I said before, there's no need to become like 51% at mining power or mining or hash power. You just take less than 30 and 30 in the other side also. And sometimes in some cases, 20% and 10%, it's enough for the attacker to take control of the nodes inside private blockchain, especially. And as I see, we see in this slide, there is the TCP between the nodes inside network, especially in blockchain network. We have find here the purple and the green. This node will be controlled all the nodes here and also the nodes here, which is taking the control of the not whole network in this example, only some of the nodes, and isolate them between the network and from the trusted nodes inside one network. This is another example of attacks in peer-to-peer network, which is a Sybil attack, which sometimes you see here the node or the trust node, it's all neighbors inside one network. It's Sybil attack, Sybil nodes, which is attacks. So they cut the network or cut the connection between the node to other nodes inside another control in the same network of the same blockchain network or Bitcoin network or other cryptocurrency network. How it's happening here? It's by giving also the same situation with the Eclipse attack by saying no balance or it's not the trust address or not the right address. Also, here there is the BTC network, Bitcoin network, and all of that it's fake nodes. They're saying there is no balance inside the network, and then send it to the computer or your node or your smartphone if you use like light node or simplified network payment verification network account. So we talk about the nodes, and then we talk about Eclipse attacks, and then Sybil attack, and then the thing which I start my question about the simple payment verification, which is I think, yeah, it's in the white paper of Satoshi Nakamoto. It's written there, and it's make the light network more like not heavy like the full node, because it's just download only the block header or take the block header of the blockchain. So there is no need to download all the full blockchain network or history or any of that. So as I can see here, you see here, they only take the private key and public key and the transaction and the marker path and the block headers, and that's it. So how it's work in Merkle tree? It's pointing the transaction from the Merkle tree from the receipt transaction 3, go to hash number 3, and then hash 23, and then the Merkle root, and then check the balance and the previous hash and the nonce, and then we get confirmed without needing to download or checking all the history from the Genesis blockchain, or this is from the beginning of that blockchain. Here, as you see here, the blockchain headers, and then the marker trees, and then the hash, and here you see the payment transaction. You just need to make sure the the transaction 1 and transaction 2, and then the input or the header of that blockchain header is inside the system, and then it's enough for that CBV node to validate one transaction inside the network. Here, I just want to point that it's CBV node or clients use the light smartphone or iPad or something without like a big hard disk or big space. So when you see here the Bitcoin start the connection, and then that is CB, and then check the handshake and handshake and the version information, which is the private key and public key, and then the Bloom filter, and then send it to that full Bitcoin client, and then get the information or get the validation from the whole full Bitcoin network. So no need to download, no need to have the whole history of blockchain. Full node, they have to have the whole history, and here it's come to the attack to this kind of nodes when in the between the full node and the client or the CBV client come here the attacker, which is similar to Eclipse attack and Sybil attack at the same time. So it sounds they are similar, but they are not similar. In the when I'm found there is like paper here and paper here, and they're trying to detect the nodes in different ways. So how it's happening here in the CBV node? There's heading like node or malicious node. They start new fork. So after some time, the node get out of the right or the trusted fork and to the other gangster fork or not trusted node or malicious node, and then will become the Eclipse or Sybil attack in the same time. And as you see here, after consecutive period, we change the node. We'll see only this fork, not all, or not the trusted fork. Also here in this next line, the same thing, but as you see here, yeah, 11 blocks here, and here only 10. And also still go with the CBV node because they have the highest X, which is in the went time. So it doesn't mean we are the trusted or the fork or the block chain. It's if they're more, it's not. Will give you more security in the CBF attack, but it also can take attack or take the control even with less blocks inside the chain. So yeah, let's summarize what I said before. We have full node and trusted node and CBP or simple payment verification node, which is 3 type. We use it now in especially in Litecoin and also full in Bitcoin and other cryptocurrency. So in the full node, we'll see all the nodes connect to the wallet, but here trusted node will be some like centralized system server or something, some master node or something like that. But here we see the node also connect to the whole network, but without having the full history or the full node like in this first topology. Yeah, and this figure will show you how much, like how many blocks now last year. Yeah, this picture we was taken last year. And you see here, if you remember the first slide, we said there is 10,000 nodes working I said, yeah, yesterday or 2 days ago. But actually, there is more than 10,000 network nodes working now inside the internet. And this will be here explained in this slide you see here. Satoshi 0161 CVE, which was 2 years ago, is 37,300 block working now. So that means there is more than 10,000 block nodes, and some of them they're full nodes and light nodes and mining and extra. Yeah, this is last slide, and this is the reference. If you have any question, I will happy to answer it for you. So
I want you to summarize what you said. So you're saying that what's the point? So there's an eclipse attack, civil attack, virus. Anyhow,
okay.
Those attacks, types of attacks exist.
Yeah.
Okay.
To summarize, when I start the first, I want to try a new direction of research, to write new paper. So I thought when I go to
So you want to prove SDN can maybe resolve those attacks?
SDN, no. I am done with SDN now.
Oh.
It's new area of research. Okay, it's something new. As you see here in the first slide, I want to try to detect the malicious nodes and try and find a solution.
Okay.
And I think the important thing to detect the network nodes nowadays is in simplified payment verification, because we use it a lot, especially in the Bitcoin and Litecoin and Bitcash.
Yeah.
So when I read the papers, I see how many attacks happen in this nodes or in this area, and I find there is eclipse attack, number 1, and number 2, Sybil attack.
Okay.
And this is the most recently attacked in the blockchain, especially if you last year in Ethereum, 51% attack. It was through the simplified payment verification. So this is the investigation. I'm trying to find how can we find solution. And this is the last picture of the nodes. Last 2 years ago, it show you there is more than 10,000 Bitcoin, Bitcoin network nodes working inside or globally. Yeah, so I'm starting like reading all papers and see what can I do. I have some idea in my mind, use some entropy system to give the node ID and give the node reputation. So any node in one system, they can find if this node is trustworthy node or not, or malicious node, and so forth. Yeah.
So you think applying SDN to blockchain is not a good idea? You stop?
Actually, I stopped because I applied to so many general, and
Didn't get us.
the review they're saying there's not something special with this your idea. It's just combined two technology together. It's okay, it's good, but we can find something new. And there is also one paper or two papers. You have the same idea was published 2 months ago.
Then you can analyze it. Then
Yeah.
Find out
So
anything you can improve or.
Yeah, last week I applied to another journal and I'm waiting for the rejection or the acceptance. But I think I need to start something new. So I have two directions. This one I think it's promising.
Okay, yeah, that's good starting point as a starting point.
Yeah.
But I want you to analyze the one already published, the applying SDN to blockchain. Maybe you can present what they've done, and based on their research, and then maybe you can add something. So, you've been doing years, right?
Yeah, almost 1 year.
So I mean, need to take a look. What is good? Good point in their paper in compare with your research. And,
Okay.
something else.
Yes.
Take a look.
Okay. Yes.
What journal did they publish?
I think IEEE magazine, #1.
Magazine.
Yeah. And #2, I think it's computer science something. It's
Bring the paper to me.
B2B. Yeah. Okay. Yes.
Sometime this week. Yeah.
Yes. Yes.
Okay. Good.
Thank you. One moment. There is one more thing, Professor. Last time we talked about solar panel, and but we didn't have the chance to talk about it. So today I will give you some highlights. I try to find or to make one architecture in this system, and I find there is we need somewhere sensors and Arduino and to make, because I looked in the net and find so expensive devices like $1,000, $900